we're taking the derivative for tangent square 3x. So we need to use the chain rule. Okay, we need to then record some for the purpose of the EMI class. So be 2 times tangent 3x, then taking derivative for tangent 3x. So be 2 times tangent 3x. And here will be just put this up so you can see it's here for you. So the derivative of tangent will be secant. Will be secant squared, then 3x. Then we do it again, just taking the derivative of 3x. So you will have 3 here. You just do use the chain rules twice. Okay. Chain rules. So this 6 tangent 3x multiplied secant square 3x. So that's the answer for this question. So function f of x is is taking the root q root of 1 plus tangent x. So f prime x actually this is equal to 1 plus tangent x to the 1/3 power. So f prime x be equal to 1/3. So move just write down the power. The power is 1/3, so put it down there. So be 1 plus tangent x will be 1/3 minus 1. Okay, and they are taking derivative for 1 plus tangent x. So be equal to 1/3 1 plus tangent x to the minus 2/3 power. And here will be 1, the derivative for 1 is 0, and tangent, the derivative for tangent will be secant square. Okay. Good. Pretty much it. And then function f of x equal to tangent sine x. So f prime x will be equal to Because the derivative for tangent is secant square. So be secant square sine x. Then take it derivative for sine x. But you can just do it directly. You can isolate extra step here. However, you can do it directly if you know how to do it. But basically, just do it. We need to use chain rule here. Okay. So the secant square sine x, and sine, the derivative for sine will be cosine x. What's the answer? Okay, then. Okay, fx equals secant square x plus tangent square x. Okay, so f prime x will be equal to 2 times secant x. And we're doing the derivative for secant x. And there will be, okay, I'm doing extra step here. The secant x dx. And the last one will be plus 2 times tangent x. And multiply derivative for tangent x. So be equal to multiply secant x. And the derivative for secant x here, right? Secant will be secant tangent. So multiply secant tangent, and here will be plus 2 multiply tangent x, and tangent, the derivative of tangent is secant square. So be secant square. So here I can put it together 4 times secant square tangent x. Okay. Question? 就你们的底的 station point point 4 you need to make the trolley a little bit because the funding. We talk about section 10.4 first, and then we go back to section 10.3. We go to finish the rest of the pages. Okay, for the 10.4, power series. Power series we call 密集数, okay, power series. And in this section, what you need to know is what is the power series, okay? And also, when does the power series converges? And you need to figure out what value of x this power series will converge. And so usually you're going to find actually it's a region, it's an interval that any value in the interval will make the power series converge. So you find the radius of convergence. We'll talk about USC 5 minutes later. And also talk about Taylor theorem. Taylor's theorem is just is a basic, is a basic theoretical foundation for section 0.5 and 0.6. And then in the power series, we are going to talk about two series. One is Taylor series, the other is Maclaurin series. Okay, Maclaurin series. 马克劳林级数 ，anyway， 密集那就是泰勒级数。And the last one we will talk about basic list of power series, which will be sometimes you can use a basic list of power series to figure out the other functions of power series. What's the power series? For instance, summation a n x n from 0 to infinity. So be a0 plus a1x plus a2x squared plus a3x cubed, and so on and so forth. We call this as power series. Okay? So it's an infinite series of a form. Okay? And usually, sometimes you will see infinite series. The power series like this is instead of x to the n power will be x minus c quantity to the n power. What does it mean? It means it's a power series centered at c. Okay, and because you look at this one, right? So if for n equals 0, the first term would be what? Would be okay, the power series. So for the last term, just the power series centered at c. So the first term was a0 x minus c to power 0. So be equal to a sub 0. Okay. So that's the first term. Okay. And the first one is just the power series centered at 0. Okay. Be this. For instance, this power series is equal to 1 plus x plus x squared divided by 2 factorial. this power series center is 0, and the center is 1. This one is the power series centered at 1, and this is centered at -1. Okay, just some example. Okay, radius convergence of power series. Okay. For instance, for this power series, right? This power series, and you can write it. You can write this power series as a function of x. So f of x is equal to summation n starting from 0 to infinity a sub n x10. Okay. Because the center is c, so be x minus c to the power. And so we try to find the value of x such that this series converges. Because this is a function of x, right? Right? So we are finding the values in the domain such that this series converges. And for this, right? If I plug into C, when x equals C, right? X equal to C, then you can get F of C will be equal to 1 because summation C minus C to n power, so be equal to summation n equals 0 to infinity a n. Let's see the x n. So you plug in from n0, and the first term will be a0 multiplied 0 to your power multiplied. Sorry, here should be c. Because x equal to c. I shall plug in x equal to this is correct. And plus a1 multiplied 0 to the 1 power plus a2 multiplied 0 to 2 power. So on and so forth. So your gap is a0 because this is the defined equal to 1. 0 to the 0 power is 1.上课不要趴在桌子上，真的。这样我就会认为你就在睡觉，真的。那如果真的这么累，我就休息吧。Okay, so because this series equal to this, what does it mean? When the series equal to constant, so it converge. So when x equal to c, we imply what? We imply this. The summation converges. So what's the radius of power? Radius of convergence. What's the radius convergence? Radius convergence would be, because we know C, if x equal to C will make the series converge, okay? So B equal to C is here. And finding the power, now finding the power, find the radius. So which will be R here, R there. It's a radius. And the point here will be C minus R, C plus R. Convergence. R is a radius convergence. So finding at least when, so finding R such that when x is grown to this interval, we imply this is not in the textbook or in my lecture notes, so you probably need to copy down. This part just I just can organize and write in my own word. Okay, so but how to find the radius convergence? Basically, it's not difficult. What you need to do is just using the ratio test. Okay. I can recap a little bit. So let's see the power series. Center is C. Okay, and it's not difficult to find out. When x equal to C, the series H is equal to A0, A sub 0. Hence, so the series converges when x equal to C. This converges at x equal to C. Now we want to find out. What other values on x will make a series convergence. So you have to